Hello everyone, good evening and welcome to the second week of the live interactive sessions for the course on Integrated Waste Management for a Smart City offered through NPTEL. My name is Sethu Vinayagam and I am a PhD scholar in the Department of Civil Engineering at IIT Madras. So before we start this week's session, so we will first take a look at what were the concepts that were covered in this particular week, right, which is week two. And so we will just take a look at that, and then afterwards we will look at some of the problems related to these concepts and how to solve them. Okay, so in week two, there were five lectures included, right? So the first lecture of week two, which is the sixth overall, continued with the landfill basics that were started in the last lecture of week one, right? So in lecture six, we saw about we continued with the landfill basics, and in lecture 7 we started with how we can characterize waste, right? So there are different ways by which we could characterize, right? So the first of which was based on regulations. So regulations give us two ways. So one is it gives us a list of certain criteria. If a particular waste satisfies those criteria, or it comes under those criteria, then we would characterize them as hazardous or non-hazardous, right? And also in this particular lecture we also looked at one particular test called the TCLP test, which stands for toxicity characteristic leaching procedure test, right? And so we saw how we can find out what is the toxicity characteristic of a leachate, right? So from a landfill we know that it produces leachate over time, and how do we characterize what is the toxicity of that particular leachate, right? So this is one particular and a very widely used test, the TCLP test. And then in lecture 8 we moved to how do we characterize waste based on the physical properties, right? So like density and moisture content, how do we quantify particular waste based on these physical properties. And then in lecture 9 we continued with that, and then looked at other properties such as porosity, right? So how do we need that? Because we need to know, based on the porosity we know what is going to be the how much moisture can a particular volume of solid can hold, right? So that is important, so that we know how much leachate it can have, how much gas content it can have, right? And then in the last lecture, lecture 10, we looked at how how we can find the average property. So we until now we looked at what are the different properties given a particular type of solid, right? Solid or a fluid. But a waste stream is not homogeneous. There are going to be different mix of different types of wastes, right? So how do we determine the average properties of this mix of waste? So that was covered in the last lecture of this particular week. So what we will do is we will look at some sample problems, right, that are based on these concepts, and then see how to answer them. So we'll follow the same format as we have been following. So we will look at some MCQ types and MSQ type of questions. So that will help you in answering the assignment questions, which will be on the in the same format. Okay, so the first question is landfill leachate with lowest pH value is generally found during which stabilization phase? And the four options are methane forming phase, final aerobic phase, acid forming phase, and preliminary aerobic phase. Okay, so if we look at the landfill stabilization, it has four phases, right? So we looked at this in one of the lectures, right? So and the four phases are listed here, but they are not in the correct order. So if the first phase would be the aerobic phase, right? So it starts with the preliminary aerobic phase, and then we move into an anaerobic phase, which is the acid forming phase, followed by the methane forming, and finally we once again move into the aerobic phase, right? So that is the last one. So there are these different phases, and throughout these different phases, leachate is going to be produced at all of these different phases, but the pH is not going to be constant. It's going to keep varying throughout the stabilization phases. So at which phase is it going to be the lowest? So what do we mean by lowest? What happens when the pH is low? It means that the leachate is more acidic, right? So when the fluid is more acidic, it's going to have the least it is going to have a very low pH, right? So out of these four phases, the lowest pH will be found in the acid forming phase, right? Why? Because as the name suggests, this is the phase of the landfill stabilization, where the waste molecules, right? The higher order molecules present in this waste is going to be converted into lower molecular weight compounds, and then into acetic acid, right? So if we look at the pH of the leachate across these different phases, we see that starting from the preliminary aerobic phase, the pH keeps reducing, and as we enter the acid forming phase, the pH reaches the lowest value, and then it slowly starts increasing once the acid forming phase comes to an end, and when we go into the methane forming phase, it stabilizes and then remains constant, right? So because of the acetic acid which is being produced in this acid forming phase, the pH is going to be the lowest in this particular phase. So that's why the correct answer to this is C, acid forming phase, right? Okay. So next we'll move on to question 2. Which of the following is not generally found in landfill gas? So the options are methane, CH4, carbon dioxide, argon, and hydrogen sulfide, H2S. Okay, so the answer to this is option C. Okay, argon. So argon is a inert gas, right? So when we look at a landfill, a landfill gas, it typically contains different gases, right? It contains methane. We know that it contains carbon dioxide. There'll be some water vapor as well, which will be produced, and then there'll be hydrogen sulfide and some other non-methane organic compounds. And in some cases, if it is some hazardous waste, so in those cases some vapors from heavy metal so can also be present in the landfill gas, right? But it is not typically found. These the ones listed here are what are typically contained in a landfill gas. So if we look at this, we don't have argon, but we have all the other three: methane, carbon dioxide, as well as hydrogen sulfide. So that's why it is option C, argon, because the question is asking which is not found, right? So in answering these types of questions, what you could do is you could do follow the elimination strategy, right? So you start eliminating those options that you know are not the correct answer. So in this case, as we know, it is methane, carbon dioxide, and hydrogen sulfide. As we know, they are present in the landfill gas, so we can eliminate them and we are only left with C, argon. So that's one way we could answer these types of questions. All right, so moving on to question number 3, again related to the landfill gas. So why is the emission of this landfill gas to an open air is a point of concern? If we don't collect this landfill gas and just let it open, right? So it's a point of concern, but why is that? So there are 4 reasons given us. One is only due to its odor, only due to its toxicity, only due to the presence of greenhouse gases, and 4 is all of these due to the odor, toxicity, and presence of greenhouse gas and explosive gases, right? So as we saw, there are a mix of different types of different gases in a landfill gas, right? So each of them is going to have different characteristics, right? So some of them are listed here. So the answer to this is D. So all of these are a problem with landfill gases. So some of them exhibit some of these characteristics. So as we saw, there is methane, carbon dioxide, hydrogen sulfide, right? Uh, so which is going to give the odor issues? It's going to be hydrogen sulfide and methane, right? Mostly it is methane because that is going to be in the having the largest volume, right? So it's mostly from methane. And then toxic. So which is toxic? So CO2 can be toxic in higher concentrations. It's also a greenhouse gas, as well as methane is also a greenhouse gas. And also explosive is hydrogen sulfide. Hydrogen sulfide is known to be explosive, right? So all of these are issues that comes from emitting landfill gases to open, right? So that's why it's a point of concern that we should not be letting it out in the open and properly handle it. All right. So then question four. So this is about the toxicity characteristic leaching procedure, the TCLP test, right? So this was covered in the lecture 7. So the question is, what is the correct order that is followed in this particular test? So there are multiple steps to it, right? So we see in the options the different steps that are in this particular test, but they are not in the so they are rearranged. So in only one of the options the correct order is given. So the question is, which of the is the correct order? Okay, so the correct order of this particular test is given in option A, right? So first we start with the solid waste, right? So we receive the solid waste, and then the second step is to reduce its size. So we break this solid waste into smaller chunks of size less than 1 centimeter each, right? So we divide them into these small blocks. And why is this size reduction necessary? What does a size reduction do? What it does is it increases the surface area, right? So the area that is exposed is going to be much higher than the original solid waste that we had, right? So by breaking down it into smaller, very small pieces, we are going to have much larger surface area. And why is that necessary? Because when we are trying to characterize the toxicity, we want to be more conservative, right? We want to be more strict, right? Because it has potential to ultimately affect our groundwater resources, right? So we want to be more conservative and more stringent. Therefore, we are trying to increase the surface area so that the reactivity of the waste increases, right? So once we do the size reduction, then we go for the leaching. Once we have more surface area, then we do leaching. How do we do that? So we take 100 grams of this reduced sample, and then leach it in a we add it to a leaching fluid, right? For 18 hours we keep that in the leaching fluid with at an rpm of 30, right? So after 18 hours we take this, so it would be leached in so the leachate will be produced, and then we take that after 18 hours and then filter, go through the filtration. So we filter the solid waste and then get only the leachate. Why do we do the filtration? Because we are interested in characterizing the leachate, right? So because that is what is going to finally percolate through the soil, or can percolate through the soil and reach and affect our groundwaters, right? So that's why we are interested in the leachate. So we filter out. So that is the next step. And the final step, once we have obtained the leachate, is to analyze it and find out what is the concentration of different chemical components in it, right? So and then we compare it with the standard and then determine whether this particular sample is toxic or not, right? So that is the correct order in which we do the toxicity characteristic leaching procedure test. Okay. Yeah. So there is a question in the chat. If the sample is heterogeneous, is it possible to take the uniform sample? Uh, Okay, so what we could do is we could try to um, separate it out before we do this, right? So we could actually separate this out into these different components, right? And then we could conduct this test for each of that separately, or it need not be completely homogeneous as well, because ultimately it's not going to be uh, representative if we're going to take only a particular homogeneous set, right? So we can it need not be totally homogeneous. And yeah, again, with respect to uh, size reduction, how is it possible to do to less than 1 centimeter for everything? Again, I think we won't do it for everything. We try to reduce it to very small size as possible, right? So our aim is to have a larger surface area so that we could make this more reactive, so that we will get a leachate in a short period of time, right? So that is our objective. So if it is not going to be, ultimately we look at it from the landfill. It's not going to be less than 1 centimeter in the landfill, right? So we are not going to break everything when we are ultimately going to put it in the landfill. So in that so there we won't be reducing everything. So with that, it should still be representative even if we don't get it to less than 1 centimeter for all the time. Okay. Any more questions? Yeah. So we want to be as conservative as possible. Okay. So moving on to question number 5. So this is with respect to the physical property, right? So how do we? This is one such property called the moisture content. So the wet weight of a particular solid waste with crucible is 55.11 grams, and the dry empty weight of the crucible is 43.22 grams. The oven dried weight of the crucible with sample is 50.13 grams. So we need to calculate the moisture content of the solid waste. Okay, so I will give you a minute so you can try to solve this, right? In the meantime, I'll just create a poll, and then once you solve it, you can answer in the poll. Okay, so I think it's straightforward. If you know the formula for moisture content, you could uh, go ahead and calculate it. So take a minute and try to solve this. Yeah, once you solve it, I have created a poll, and then you can respond to that poll with your answer. For those who are not familiar with the poll, so you can find it in within the activities section. So in the bottom right, if you're if you're connected via a desktop or a desktop browser, you can find the activities button on the bottom right, and within that there will be a section for polls, and you can find it there. Okay, we have some answers. I'll wait for a few more seconds for others to fill in. Okay, I think that's enough time for this particular question, right? So there are a few answers. So some think it is C. There is one answer for B. Okay, so the correct answer to this is actually B. Okay, how is it B? So we'll see how it is option B. Okay, so what do we know about moisture content? So moisture content is nothing but the mass of uh, water divided by the total mass, right? So that is the moisture content, right? So if you want to express it in percentage, you multiply it by 100. So we are given all this information to get the mass of water and the total mass, right? So how do we get the mass of water? So we are given the waste or the weight of the wet waste, so which is 55.11 grams, and this weight is inclusive of the weight of the crucible itself, right? And we are also given the dry empty weight of the crucible. Okay, and also we are given the dry weight of this waste along with the crucible, which is 50.13. So if you want the mass of water alone, we should subtract the wet waste weight with crucible, and subtract it with the weight of the dry waste, right? So 55.11 is the weight of wet waste, and 50.13 is the weight of the dry waste. So the difference between these two is nothing but the mass of water, right? So we know that we got the mass of water. The total mass is nothing but the mass of the wet waste minus the weight of the crucible, right? Because this wet waste weight is given along with the crucible, so we have to reduce the weight of the crucible to get the mass of that, or the total mass of the waste, right? And then we multiply that by 100. So if you simplify this, so the numerator will become 4.98 divided by 11.89, right? So and then multiply by 100. So this simplifies to 4.41.88%, right? So that's how we get it. So if you remember, the moisture content, it's the ratio of mass of water to the total mass. And once you know that, you could derive these two quantities from the information that is given. Okay, was that clear? Why 41.8 and 88%? Any questions?
No, sir, clear.
Okay, so then we'll continue. Just give me a second. Okay, so here's question number 6. If the uh, energy content of solid waste as discussed is 1550 kilojoules per kilogram, then find the energy content on a dry basis if the moisture content of the solid waste is 15%. Okay, so we are given that for a particular solid waste, right? So it is the total solid waste, right, with some moisture content. So its energy content is 1550 kilojoules per kilogram. And if the moisture content is known to be 15%, then what will be the energy content for the dry solid waste? Okay, again, you can take a minute to answer it. Again, I'll create a poll for this one as well. Any answers? Okay, so I'll solve it, but you can try to answer it based on your understanding. What do you think would be the answers? Or if you don't know, just take a guess. So, what do you think? Is it going to be lower than 1.5 megajoules or higher? So, based on that, you can reduce the number of options that you have. Just take a guess. Right, so it is given for the wet waste, it is 1.5 megajoules or 1550 kilojoules, right? So, if you remove water from it, if it was totally dry, what do you think would have been the energy content? Okay, so we just have one answer, which is option D, almost same as what is in the question, right? So 1.5. So somebody thinks it won't change. Okay, all right. So we will look at the answer. So it is actually option C, 1.8 megajoules per kilogram. Okay, so why is that higher? Because think of it like if it is a dry waste, it's going to have a larger energy content than if it is a wet waste, right? So if you think of it like if you add more moisture to your waste, it's going to it's like diluting it, right? So it is not going to give you as much energy as it would have if it was totally dry. So if you want the energy content of the corresponding dry waste, what you should do is divided by 1 minus the moisture content. So here it is 15%, right? So it means 85% of it is solid, right? It's a solid mass. So 1 minus 0.85. So that is your factor by which it will be higher for the dry component, right? So it will be 1550 by 0.85. So to understand why that is, so we will see why that is. So let me again reshare my screen. Okay, so think of it like this. Say if we have say 100 kilograms, okay, of just dry waste, okay, totally dry waste. Then from we'll just do a back calculation, okay. So we know that it is going to give you 18 kilojoules, okay. Suppose now this out of this 15% is the moisture content, okay. So what does that mean? 85% of this 100 kilograms is your solids, right? Out of this 100 kilograms, so that is what is going to give you the energy, and the rest 15% of it is nothing but water, right? So from this you are not going to derive any energy, right? So this left hand side is totally giving you this 18 kilojoules, right? But we know that the second term, this is not giving you the energy. It's only this 85% of this solids. So that's it. Okay, it's not going to give you 18 kilograms. It's going to give you 85% of it. Why? Again, because it was this 100 kilograms of the dry waste that was capable of giving 18 kilojoules. Now we don't have 100 kilograms of dry waste, which is solids. We have only 85% of it now. So the energy will also be now reduced by 85, will only be 85% of that 18 kilojoules. So now what we have in this particular question is actually this left hand side. What is the energy corresponding to this particular part, right? So a particular solid waste is giving you 1550 kilojoules, but that is having 15% moisture content. So that is this left hand side. Okay, so that one is giving you 1550 kilojoules. Okay, again all this is per kilogram, so this is equal to 0.85 times whatever is the energy that you will get from a dry waste. If it didn't have any moisture content, whatever is the energy, so that is the unknown here, right? So we don't know what is that energy from the dry component alone, right? So if it had no moisture content, so if you want to solve this, so we take from the wet waste whatever was the energy that was produced, right? So we divide that by 0.85 and you'll get the x which is in the dry component. So this gives you x as 1.8 megajoules. Okay, that's how we arrive at this answer, right? So we are given what is the energy corresponding to a particular waste that is having some moisture content, and then we know what is the moisture content as well, so we need to find out what is the energy corresponding to the if it was totally dry. Okay, was that clear? Any questions?
No, sir. Clear.
Okay. Okay, so moving on with question number 7. So, which of the following statements are true related to waste composition measurements? So, option A is real solid waste sample is collected in source specific approach. Option B, real solid waste sample is collected in materials flow methodology. Option C, the mass of materials entering the waste stream and their lifespan is used in the materials flow methodology. D is the same thing, but the mass of materials entering the waste stream is used in the source specific approach. Okay, so this was one way in which a waste can be characterized, right? So we saw the different ways in which waste can be characterized in the lectures. So one particular way was to characterize them based on the composition of the different components in the waste, right? So there were two methodologies that we saw. One was the source specific approach and the second one was the material flow approach. Okay, question is not visible. I have already shared the screen. Can somebody else confirm if they are able to see the screen?
Yes, sir. I am able to see the screen.
Okay. Abhishek, if you can leave the call and rejoin, I think that would help. Okay. So these are the two methodology that we saw. The source specific approach. So what is the source specific approach? It is where we actually go to the place where the waste is getting generated. So right, it's like in terms of households, right? Because in municipal solid waste we generally deal with household waste, right? So we go to households, collect the samples, collect the wastes from the source, and then try to see what are the different waste components in these wastes. All right, that is the source specific approach. As the name suggests, we go to the source and then collect it. Whereas in the materials flow methodology, we do not look at the waste themselves, but instead we see the different products that are entering the market, right? So what are the different products that are entering? How much is being sold? So we look at what is the sales that is happening for the different products, and also we know for different products what is the lifespan or the shelf life, right? So how long before it enters the waste stream, right? So we know that for different products on an average how long a product is useful, right? So with that we will be able to estimate when does it enter the waste stream, when does it become a waste, right? So with that we will be able to calculate how much waste will be generated at a particular point in time. So that is a material flow methodology. Here we do not directly collect the waste, but we try to estimate it from the products, the amount of product that's being sold, right? So that's how we try to those are the two ways in which we can characterize the waste composition. Okay, So that is given in options A and C correctly, right? So B and D are actually interchanged, right? So that is not the correct definition of what happens in this in these two methods. Okay, so that, moving on to question 8. Which of the following statements are true for the physical characteristics of solid waste? So again, we talked about some of the characteristics, right? We saw density, porosity, moisture content, and so on. There is specific gravity. So here we are talking about bulk density, dry density, and density as such. So option A, bulk density is greater than the dry density for a sample. Option B is that dry density is greater than bulk density. C is density is weight or force per volume, and D is density is mass per volume. So we need to pick out the correct ones. So the answers are, yeah, as people pointed out in the comments, it is options A and D. Those are the correct definitions of bulk density as well as density, or the correct statements about bulk density and density. So why is bulk density greater than dry density? So what is the formula for bulk density? It is the total mass divided by the total volume, right? Whereas for dry density, it is the mass of solids divided by the total volume, right? So if you compare these two, the denominators are the same. It is the total volume, but the numerator is different. So for bulk density, it is the total mass. For dry density, it is only the mass of solids. So the mass of solid is going to be lesser or at least equal to the total mass, right? Uh, so that's why bulk density will be always greater, or in the worst case, it can only be equal. It can never be lower than dry density. So option A is correct, whereas B is not true. B is not possible. So that is true. And C, we are talking about density. Again, the definition of density is mass per volume, right? How much mass is there per unit volume. Whereas C is saying it is weight per volume. So that is not correct. So that definition is for specific weight. So weight per volume is called specific weight. So the correct definition is mass per volume for density. So the correct statements are A and D. Okay. So moving on to question number 9. Which of the following represents the phases of landfill stabilization? So again, we looked at this, right? So in one of the previous questions, we talked about this. But here one of them is not correct. One of this is not a correct phase. So we need to identify that. So option A is median forming phase. Option B, preliminary anaerobic phase. C, acid forming phase. And D is a preliminary aerobic phase. So which of these represent the correct phases, or which of this is not representing the correct phase? So either way you can say. Okay, so we'll answer which of these are correct. So multiple answers will be there. Okay, we have some answers in the chat. A, C, and D. Yes, that is correct. A, C, and D are the correct are phases that are present in a landfill stabilization. So if you remember this process diagram from the lectures, so initially we start with an aerobic phase, right? So that's how it starts. So that's the preliminary aerobic phase. Then it moves on to an anaerobic phase, right? So once we have covered the landfill, so it moves on to that. So in which we have the first acid forming phase, followed by a methane forming phase, and finally again we have an aerobic phase to complete. So we don't have any anaerobic phase at the start of this stabilization process, right? So that's why this is a wrong option. So the anaerobic degradation takes place in the middle portion of these landfill phases, right? So we start with aerobic, end with aerobic, and in the middle we have some anaerobic phase. So that's why A, C, and D are the correct phases, whereas B is not. Okay, so moving on to question number 10. Which of the following statements are correct related to landfill gas collection wells? So we have four options. Wells connected to a gas extraction system are known as passive wells. Wells open to the atmosphere are known as active wells. And then these two are interchanged in C and D. Wells connected to a gas extraction system are known as active wells, and wells open to the atmosphere are known as passive wells. So this is based on the definition of how we define what is a passive well and what is an active well. Okay, the answers is yeah, as it is given in the comment chat, it is correct. So C and D are the correct ones. So by definition, active wells means it is the well has a gas extraction system, right? So we use vacuum to pump out the gases from this from the landfill, right? So we extract it and then we can then flare it or use for converting it to energy heat for other processes, or if we just let it be open to the atmosphere, right? So in that case it will be called as a passive well, right? So these are by definition. Okay. Then question 11. So which of these following statements are true, right? So this is coming from the regulations, right? How do we characterize a particular waste as hazardous or non-hazardous, right? So we have some listings that I mentioned at the beginning, right? So that is based on the regulations. So we have some statements from that. So but not all of these are true. So first one is toxic listed waste typically contains harmful chemicals which indicate that it could pose a threat to the human health and the environment in the absence of special regulations. B, the same thing is it could be a threat. The toxic waste, waste that is labeled as toxic, could pose a threat even when it is properly managed, and it could also be fatal to humans and animals even in low doses. And C and D are about another category called as acutely hazardous waste. So C is acutely hazardous waste typically contains harmful chemicals that could pose a threat in the absence of special regulations, and D is the acutely hazardous waste could pose a threat even if you properly manage it, and also in low doses it could be fatal, right? So according to the definitions from the regulations, so which of these are the true statements? Okay, we have an answer in the chat, A and D. Yeah, there is another answer, B and D. Okay, any other answers? So this can be a little difficult to remember, right? So these long definitions and very similarly sounding definitions, right? But they are used to refer to different they are different criteria and used to refer to different types, right? So toxic or acutely hazardous. Okay, there's another answer, ABD. So that cannot be true, right? ABD. So A and B are not the same. One is in the absence of special regulations, is what A says. B says even when you properly manage it. So that is not very, that don't go well together. So that can't be the correct choice. You can't say A, B, and D. Okay, so the correct answer is actually A and D. So when we don't have special regulations to be followed to handle a waste that is listed as toxic, so in that case if it becomes a threat, so that is called as a toxic listed waste, right? So if you manage it properly it's fine, but if you do not follow these if you do not have any special regulations for handling it, and in that case if it is going to be harmful to both humans as well as to the environment, so in that case we call that as a toxic waste, right? Toxic listed waste. And the other type of waste is the acutely hazardous waste. So what does that mean? Even when you have regulations in place, even when you follow them properly, it can still be very dangerous, right? So that is what we call as an acutely hazardous waste. So here even working with very very low doses of it is going to be very dangerous and fatal. So that is the two classes, right? So toxic means you can handle, if you handle them properly it is fine, right? So but when you don't when but for acutely hazardous, even if you properly manage it following all the regulations, it could still be very dangerous, right? So that's why it's acutely hazardous. Okay, so this is by the definition from the regulations. Okay, so question 12 again we look at toxicity characteristics. So which of these statements are true about the TCLP test? So option A, it is developed under the RCRA, Resource Conservation and Recovery Act. B, it determines the methane percentage in the landfill gas. C, it represents the MSW landfill conditions. And D, it determines the organic content of the leachate. So which of these do you think are the true statements about TCLP? So we saw the process, right? What happens in this TCLP in one of the question, right? So we know what are the steps involved. So based on that, you should be able to find out some correct options from this, if not all. Okay, A and C. Any other answers? Okay, only C. And this is a multiple select question. Multiple options could be correct at the same time. Okay, C. Everyone agrees C is true. Any other options that could be true among A, B, and D? Okay, again AC. All right, so you're correct. So both options A as well as C are true about the TCLP test. So if you look at the TCLP test, it was developed as a part of this Resource Conservation Recovery Act, right, in the US. So option A is true. Whereas B says it determines the methane percentage. So we don't deal with the gas, right? So as the name suggests, it is about the leachate, right? So we are going to test the leachate in this for its toxicity. So we are not working with the landfill gas. So B is not true. C, it represents the municipal solid waste landfill conditions, right? So that's why we looked at doing it with by leaching it with the use of leaching fluid, right? So that is trying to accelerate the leachate process. So we also try to reduce the size so that it would react and then produce the leachate and then filter out and then get only the leachate. So we are trying to replicate or be as representative of the landfill conditions or even more conservative on the more conservative side, so that we are more sure of what is going to happen, right, in the worst case. And so that is true. And option D, it determines the organic content. So that again we do not look at the organic content. We are trying to determine the toxicity. So we are trying to find out the concentration of the uh, different chemical content, right? So that's what our goal is in this TCLP. So we are not going to determine the organic content. So only options A and C are true about the TCLP test. Okay, so moving on to question 13. So again, with regard to the TCLP test, we said that we are going to use an extraction fluid, right, to do this leaching process. So which of these options give the correct pH values of the extraction fluid used in the TCLP test? So A is 2.93 plus or minus 0.05, B 4.93 plus or minus 0.05, C 2.88 plus or minus 0.05, and D is 4.88 plus or minus 0.05. So again, multiple options are possible. So we do not have a single answer to this, right? So we use uh, two different extraction fluids depending upon the uh, ways that we are dealing with. So there is one typical value and one that we use in some in not so of not so often. Okay, there is A and B as one answer and B and C as another. Okay, any other answers? Okay, these things you just have to remember. There is no other way. The values You'll just have to remember it from the lectures, right? So because these are very similar again, these are just given, right, as a part of this test. So you just have to remember the value. Okay, so again, why 4.93? Again, we don't know. It's what is specified as part of this test, right? So again, why such a low value? It's more acidic, right? So it's going to accelerate your leaching process, right? So more acidic, you will have more leaching. Okay, so the answer is, as many of you have said, it is B and C, right? So if you remember, it is the two fluids we use. One is the acetic acid plus sodium hydroxide, right? So that is the typical one that we use mostly. So it has a pH of 4.93 plus or minus 0.05. So why do we need that? We need this buffer so that the pH remains right constant. It doesn't vary too much as throughout the test, right? So it should fairly remain at the same value for the period of the test. So that's why we need the fluid with the buffering ability. So we use acetic acid again because that's what is going to be present in the landfill, right? So during the acid forming phase, the acidogenic bacteria is going to produce this acetic acid, right? So that's what is going to lead to this leachate formation, right? So we want to replicate that, so we are using the acetic acid. So 4.93 for that combination, and then in another case we can use just acetic acid with a pH of 2.88 plus or minus 0.05. So when do we use the second option is when your waste is very basic, right? So it's going, if your waste is going to have a pH of 11 or more, right? So if it is going to have a very high pH, in that case you need your extraction fluid to have more acidic, right? So it should have even lower pH than than 4.93. So in that case, it is specified that we should use acetic acid with 2.88, right, plus or minus 0.05. Okay, so yeah, so this concludes the questions for week 2. So this was the last one. I hope all the concepts were clear to you from what was taught in week 2. So any other questions that you have, any clarifications that you need before we close for this week? And you could make use of the discussion forum, right? So again, from the course page you will be able to find the link to the portal, right? You can access the discussion forum and you can post your questions there if you have any before we meet for the next week. Okay, any other questions before we can conclude? Okay, so if there are no further questions, we can close this session. Thank you all for attending, and we'll meet again next week. Okay, Friday, 6 to 7, same time. Thank you.
Thank you, sir.